Finally, we will take the previous problem and we will classify the 5 critical points. We have the 5 critical points laid out right here that we found in the previous video and the previous part of this example. We already have the first partial derivatives from our work in the previous part of this problem. To classify critical points, we're going to need the second partial derivatives. And so we'll start there. So we have f sub x. We want to take an x derivative of that to get 2y squared plus 6y. And the x derivative of y squared and y is 0. So that's where we are for f sub x. For f sub y, we start with the y derivative and take another y derivative. And we have 2x squared minus 4x as f sub y, the second derivative with respect to y. And we need the mixed partial derivative, f sub xy. Now remember, with the mixed derivatives, the order doesn't matter. We could take x first and then y, or y first and then x. We get the same thing when we do that. So let's just, we have the x derivative here. Let's take the y derivative of that. So the y derivative of f sub x gives us 4xy plus 6x minus 4y minus 6. So that is our mixed partial derivative. Now for the second derivative test, what we want to do is make a table like this table. We're going to have our point, our discriminant. The discriminant is this combination of second order partial derivatives, specific combination. And sometimes based on the discriminant, we need to also look at f sub xx, the second derivative with respect to x, and then we'll have a column for our conclusions. For the first critical point, 0, 0, if I evaluate the discriminant at 0, 0, just evaluate, for example, f sub xx at 0, 0, we get a 0. F sub y, we get a 0. And f sub xy, we get a minus 6. And if you square that, you get 36. And negative 36 squared is right here. That's this negative 36. Or negative 6 squared is negative 36, sorry. If the discriminant is negative, we can conclude that the point is a saddle point. It's not a max or a min. It's a point where in one direction the surface is increasing, and in another direction the surface is decreasing. Now we do that for all the critical points, and it turns out for most of the critical points, we get the same thing. We get negative 36. So most of these critical points, 4 of them, are saddle points. The lecture contains a picture of this surface. You can see the 4 saddle points and the local max in that picture. One of the critical points, when we evaluate the discriminant, f sub xx times f sub y minus f sub xy squared, at the point 1 comma minus 3, 2, we don't get negative 36. We get something positive. We get a 9. When the discriminant is positive, we need to then look at the f sub xx at that point. So f sub xx at that point turns out to be negative. Think of that as concave down, giving us a local maximum. So we do have one local maximum and 4 saddle points for these critical points. That's the process we're going to need to take when we classify our critical points using the second derivative test.